today's topic, that is problems on single electrode potential and cell potential. Okay. First problem, I'll take this one. Calculate the E naught. Okay. Calculate the E naught of zinc electrode. It is usually represented this way: E naught Zn2 plus bar Zn. Okay. Calculate E naught Zn2 plus bar Zn for the reaction. That is, here what we observe is a reduction reaction. For the reaction, Zn2 plus 2 electron giving rise to Zn at 25 degrees Celsius. What is given? Given is E naught Zn 2 plus bar Zn equal to minus 0.76 volt, and Zn2 plus concentration is 0.1. For this concentration, at this concentration, you have to calculate electrode potential, not E naught, it should be E. Okay. First, I'll take a Nernst equation. Okay. So, Nernst equation for a single electrode potential. I know E equal to E naught plus, here they mention 25 degrees Celsius. Okay, that's why directly I can take 0.05, both 59, in some book you can observe 592, in some book some 591. Okay, N log concentration of Mn plus. Okay, now E naught is given. Yeah, E naught Zn2 plus bar Zn is given. That is equal to minus 0.76 volt. Okay. Then Zn2 plus concentration is given. That is 0.1 m. Okay. You have to substitute this in the equation. So E equal to, here it is given minus, I'll write 0.76 plus 0.0592 by N. How many electron transfer we observe here? N equal to 2. N equal to 2 divided by 2 log concentration, that is 0.1 m, or I'll write just 0.1. Okay. I can write it as just a 0.1. Okay. Then how to find 0.1 log of 0.1 minus 0.76 plus 0.0592 divided by 2 is nothing but 0.0296, and log 0.1 is nothing but minus 1. So what is the value you get? E of Zn2 plus bar Zn, electrode potential of zinc electrode at 0.1 m concentration becomes minus 0.7895 volt. Okay. Problem is this, and you try to write these things. Okay. You have to submit all these problems. So that's why simultaneously while solving, you write it, and even you use calculator, and you should answer it. Okay, next, this is the first one, so that's why I'll directly myself I write the answer. Otherwise, you have to answer. Okay, calculate and answer it. Okay. The second problem, the standard electrode potential of zinc electrode is minus 0.76 volt. What will be the potential of 2m solution at 300 Kelvin? Okay. What is the difference you observed between the previous and this one? In the previous problem, they mentioned at 25 degrees Celsius. So you can use equation, standard equation at 25 degrees Celsius. But here, the temperature is different. That is 300 Kelvin. And in the previous problem, they given the concentration is 0.1 mole. Here, here it is 2 molar. Okay. Say, I'll take the general equation. Usually, while solving the problem, first you have to write the equation. So, I'll take general. For general equation, you can write it like this. Mn equal to E naught Mn plus bar Mn plus 2.303 RT by NF log concentration of Mn plus. I'll substitute known things, They given the standard electrode potential minus 0.76 plus 2.303 into, and you know the R value is R is nothing but 8.314 into temperature 300 divided by n number of electron. What is this electrode we use? Zinc electrode. So zinc electrode takes 2 electron, okay, Zn2 plus takes 2 electron, giving Zn. So n equal to 2, okay. I'll take 2 here, n into 96,500, okay, log concentration of 2, okay. See how much it becomes. Minus 0.76, 0.02976. Yeah, is it right?
Yes, ma'am.
Okay. Now final one. Final minus minus 0.750 volt. This is the potential developed when you use a 2 molar solution. Okay, when you use a 2 molar solution, you will get, this is the final correct answer, 0.7570. Okay, 0.7570 volt potential is developed. Next, I'll take next problem. This both we arrive taken the solve the problem based on a single electrode potential. Okay. Now I'll take cell potential. How we solve the problem related to a cell potential. Okay. Here a cell uses zinc Zn2 plus bar Zn. A cell uses Zn 2 plus bar Zn and Ag plus bar Ag electrodes. Write cell representation, half cell reaction and net cell reaction. Calculate the EMF of the cell. Here given thing is E naught Zn2 plus bar Zn equal to 0.76 volt and E naught Ag plus bar Ag equal to 0.34 volt. Okay. Here they given not only to calculate E cell, you have to write the cell representation, half cell reaction and net cell reaction. Okay. First, you have to find among the two electrode, which one act as anode and which one act as a cathode. The given thing is E naught Zn2 plus per Zn is minus 0.76 and the silver electrode potential is 0.34 volt. Okay. The higher the reduction potential, here the reduction potential of Ag electrode is high. Yeah. See, reduction potential of Ag electrode is high, so it is taken as, or it should act as cathode. Okay, you already know the one which possesses a higher electrode potential act as cathode, and the other electrode, zinc electrode, act as anode. So we can write, based on this, we can write the cell representation. We can write the cell representation where first we have to write an anode, that is Zn giving rise to Zn2 plus 2 number of electrons. So that's why first we write the anode representation. Zinc bar Zn2 plus. Here the single vertical line indicates the phase change. Okay. Then you have to write the double vertical line, that is the salt bridge. Double vertical line is the salt bridge. The two electrode is connected by means of a salt bridge. And then you write the cathode representation, that is silver electrode Ag plus bar Ag. Okay. First anode, then cathode. And you know, here they are not mentioned the electrolyte concentration. Usually in the cell will take aqueous solution of this electrolyte. It's a simple way representation of electrode. First you have to write a anode. Okay. First write anode electrode, then cathode electrode, then cathode electrode. And these two electrode is connected by means of a salt bridge, represents by means of a double vertical line. This is a representation. Now I'll take the next thing, that is you have to write the half cell reaction. So the first you write at anode, what is the reaction take place? That is oxidation. Zinc giving rise to zinc ion with the liberation of 2 moles of electron. Okay. At cathode, what is the reaction? That is reduction reaction. So reduction reaction, that is Ag plus ion takes electron giving rise to Ag. Here silver can able to give only 1 electron. Okay, the state says so that it can take stability. But zinc 2 electron can able to give. Okay, so that's why while writing the silver, you have to write a single electron. But it is a spontaneous redox reaction. So the second equation should be multiplied by 2. Okay. Number of electron transfer or the number of electron liberated should be equal to the number of electron consumed at cathode. So that's why the second equation should be multiplied by 2. Now, the next question is you have to write the cell reaction. So the sum of this is nothing but a cell reaction. Okay, that is cell reaction. Zn plus 2Ag plus. I have to multiply second equation by 2 and this becomes 2 electron get cancelled. Zn2 plus 2Ag. This is a net cell reaction. Now, the final thing you have to calculate EMF of this cell, electromotive force of this cell. EMF equal to E naught cathode minus electrode potential of cathode minus electrode potential of anode. And you know the which electrode act as cathode, that is silver. So can write E naught Ag plus bar Ag minus E naught Zn2 plus bar Zn. And E naught Ag plus, you know, it is point, again it is wrong given. Here you just take change in the this one. It is not 0.34, it should be 0.8 volt. Okay, in the problem itself it's wrong. It is 0.8 minus of minus 0.76. Okay, so 0.8 minus of minus 0.76, it becomes 1.56. Here I'm not taking any Nernst equation. Here directly I arrive the cell potential based on the standard electrode potential of zinc electrode and the silver electrode. Clear? See here what I taken is why I am not taken Nernst equation, because they are not mentioned the electrolyte concentration. If they mention the electrolyte concentration, then that electrode potential or the cell potential that depends upon the electrolyte concentration. But here I'm not taken electrolyte, I'm not consider electrolyte because they are not mentioned. Clear? See in this problem they given the two electrodes. First you have to write the cell representation. Silver and zinc electrode given. Silver electrode potential is high compared to zinc electrode. So that's why it is taken as a reduction electrode. So cell representation is zinc giving rise to Zn2 plus, or you can write it as cell represent Zn bar Zn2 plus double bar Ag plus bar Ag. At anode, oxidation takes place, so Zn giving rise to Zn2 plus 2 electron. At cathode, Ag plus electron giving rise to Ag. So here it is a simultaneous reaction. The number of electron liberated is equal to the number of electron consumed. So it should be balanced. So that's why the cathode reaction should be multiplied by 2. So the final cell reaction is Zn plus 2Ag plus giving rise to Zn2 plus 2Ag. Next step, you have to calculate the cell potential. EMF of the cell is equal to E naught cathode minus E naught anode. Here cathode is a silver electrode and anode is a zinc electrode. So silver electrode potential is 0.8 volt and the zinc electrode potential is minus 0.76 volt. So the net EMF developed by the cell is 1.56 volt. Okay. Is it clear? Any doubt? Representation of a cell, then calculation, reaction, anode reaction, cathode reaction, or selection of anode and selection of cathode. Any doubt? Any doubt? Please.
No, ma'am.
Huh? It's,
No,
it's
ma'am.
clear. Okay. I observed the box. Okay. Now, next problem. That is related to cell potential, Nernst equation, or the determination of cell potential. Okay. Here, calculate the cell potential for the following cell. That is, iron interact with the cupric ion forming iron, ferric ion plus copper. When cupric ion concentration is 0.3 m and Fe2 plus ion concentration is 0.1 m, given E naught cell is 0.73 volt. You have to calculate cell potential. Okay. Here, what are the things given? They given the cupric ion concentration and the ion concentration. Okay. But they are not mentioned the electrode potential of copper and the electrode potential of iron. Okay. The copper electrode potential is 0.34, whereas iron electrode potential is minus 0.44, I think it's volt. So iron electrode potential is less compared to copper electrode potential. So iron act as anode and copper electrode act as cathode. Okay. So here you can write Fe electrode act as anode and Cu electrode act as cathode. This is completely based on the reduction potential of the two electrode. Okay. Next, I'll write the Nernst equation for a cell potential. Okay. E equal to, or E cell equal to E naught cell. I'll take minus sign. Okay. Minus. And at 25 degree, I'll mention because they are not mentioned the temperature. So I'll take for 25 degree, 0.0591 or 2. In some book they given 2 by n log concentration of the product by the concentration of the reactant, Fe2 plus, or you can write it as a product by the concentration of the reactant. Or you may represent this one is a concentration of the product means oxidation species divided by, that is, reduction species, because here I took negative sign. Okay. Now E naught cell is given, that is 0.73 minus 0.0592. How many number of electron transfer observed? Number of electron transfer is 2. Yeah. Here 2 electron is observed. Here also 2 electron. Number of electron transfer is 2 log product Fe2 plus ion that is 0.1 divided by 0.3. Okay. Log of 0.1 divided by 0.3, you can get some numerical values. Log of that one you find out. Okay. Then multiply by 0.0592 by 2. Okay. 0.73 minus 0.0296 log 0.1 by 0.3. Okay. See, you will get after this, you can get, I think, 0.8 volt potential. Okay. That is E cell. This particular this cell, you will get 0.8 volt of potential. Okay. In this way, you can able to calculate the cell potential. Any doubt under this? Any doubt? Any doubt? Okay. Next, I'll take similar type of problem. I'll take the similar type of problem. That is, what is the cell potential of the electrochemical cell in which the cell reaction is Pb2 plus cadmium giving rise to Pb plus cadmium ion. Given that E naught cell is equal to 0.277 volts. Temperature given is 25 degrees Celsius and cadmium ion concentration is 0.02 m and the lead ion concentration is 0.2 m. Here, from this cell reaction itself, you can predict anode and cathode. Even in the previous problem, from this cell reaction, you can predict anode and cathode. Here, the cell reaction, you can see Pb2 plus, okay, giving rise to Pb. That means it should consume 2 electrons. Yeah. And the second thing is Cd giving rise to Cd2 plus. That means by giving 2 electron, it converted to Cd2 plus. Okay. So the Pb consume electron. That means it acts as cathode. Yeah. Cadmium gives electron. So act as anode. Clear? So this way you can predict the anode and cathode. Anode and cathode. Now, I'll take a simple cell Nernst equation. E cell is equal to E naught cell. Here, I'll just change. I'll take a positive sign. In the previous case, I took a negative sign and I calculated. Here, positive sign. If you take a positive sign, then reduction species comes to numerator. Okay. 0.0592 by N log concentration of reduction species, that is reactant, by the concentration of the product, that is oxidation species. Okay. This way. Now I'll substitute the values. 0.2, how much it is? 0.277 plus 0.0592. Number of electron transfer is again 2. Log concentration of reduction species. The reduction species is lead. Yeah. And reduction species is lead. I'm again confused. Okay. Oxidation species is a cadmium. Lead is a reduction species and the cadmium is an oxidation species. So lead concentration is 0.2 divided by 0.02. Is it right? Clear? Clear? See here, I took a positive sign here. So that's why numerator term reduction by oxidation. The reduction species is a lead. Oxidation species is a cadmium. Okay. Now, that equal to 0.277 plus 0.0296. Okay. How much it becomes? Log of, calculate. 1. How much? 10. Log 10 is how much? Log 10 is 1. So you can get like this 0.277 plus 0.0296. So the final answer is cell equal to 0.3066 volt. Okay, this is the final answer observed. Okay. Now I shall move to the next problem, that is an electrochemical cell consists of magnesium electrode in 0.084 m magnesium nitrate solution, that is magnesium metal is dipped in a 0.084 m magnesium nitrate solution, and silver electrode means silver metal is dipped in a 0.70 m AgNO3 solution. The standard electrode potential of Mg and Ag are minus 2.363 volt and plus 0.80 volt respectively. Represent the cell, write the cell reaction and calculate EMF of the cell. Okay, here the given the electrode potential of the two electrodes, magnesium electrode and the silver electrode. See, what is the given thing is E naught Mg2 plus bar Mg is given, that is minus 2.363 volt, and silver electrode E naught Ag plus bar Ag is 0.8 volt. Okay. Among the two electrodes, silver electrode possesses a higher electrode potential. Okay. See, Ag electrode act as cathode. Why? Because it is a high electrode potential, and Mg electrode act as here. Now you already predict which one acts as anode and which one cathode. Now you represent the cell. Okay, representation. See, first you have to write the anode Mg2 plus bar Mg double bar Ag plus bar Ag. This is a cell representation. Now you have to write the cell reaction. While writing the cell reaction, before you have to write the half cell reaction. Anode, at anode, the anode is a which one? Magnesium, Mg, giving rise to Mg2 plus 2 electron. Okay. At cathode, that is Ag plus electron giving rise to Ag. This second equation should multiply by 2 because simultaneous reaction. So you can get Mg plus 2Ag plus giving rise to Mg2 plus 2Ag. Okay, now already written the cell representation. Now you have to calculate EMF of the cell at a two different concentration. The magnesium electrolyte is 0.084 and silver electrolyte is 0.70 molar. Okay, at this, for this concentration you have to calculate the electrochemical cell potential. So for that you have to write the Nernst equation. E cell equal to E naught cell. Okay, E cell equal to E naught cell plus 0.0592 divided by n log concentration of reduction species by the concentration of oxidation species. Okay. See, E naught cell is nothing but E naught Ag plus bar Ag minus E naught Mg2 plus bar Mg. Yeah. Plus 0.0592 by n log concentration of reduction species. Which one is the reduction species here? That is silver. Yeah, I'll take concentration of Ag plus to the power 2. Why I represent to the power 2? Here, if you observe the reaction involves the consume involves the two number of electron. Here you mentioned the 2 Ag to the power 2, Ag plus to the power 2 you have to mention. Clear? That's why I'll take here Ag plus to the power 2. And you know the electrode potential of silver electrode 0.8 minus of minus, that is 2.363 plus 0.0592 number of electron transfer to log concentration of Ag plus ion, that is 0.7 to the power 2 divided by this one is 0.084. Either you can write log a to the power 2 a to the power a square by b, or 2 log a by b. Okay, anyway you can write it. So here this value we can get 3.163 plus 0.0296. Okay, then log of this log of 0.7 to the power 2 divided by 0.084. After calculation, we'll get E cell equal to 3.1856. You just use calculator and calculate it. You just make the practice, otherwise it is difficult. Okay. Log 0.7 to the power 2 divided by 0.084. What the value you get, find the log, multiply 0.0296, add 3 point to that, add 3.16, 3 will get 3.1856 volt. Okay. See here in this cell you are given two electrolyte concentration. Magnesium electrolyte concentration is 0.084 and silver electrolyte concentration is 0.70. Then standard electrode potential of magnesium is minus 2.363 and the silver is 0.8 volt. Represent the cell. So Mg2 plus bar Mg double bar Ag plus bar Ag. And here better you can represent, write the electrolyte concentration. Mg is 0.084 and here silver is 0.7. Okay, electrolyte representation. Then at anode oxidation, Mg giving rise to Mg2 plus 2 electron. At cathode reduction, Ag plus electron giving rise to Ag. So the net cell reaction is Mg plus 2 Ag plus giving rise to Mg2 plus 2 Ag. Then cell potential, Nernst equation, E naught cell, E cell equal to E naught cell plus 0.0592 by n log concentration of reduction by concentration of oxidation. When you write reduction species in the numerator, you have to take positive sign in the Nernst equation. If you take the oxidation species in the numerator, then you have to take negative. Here you can get the final answer is 3.1856 volt. Okay. Any doubt under this? Any doubt? Any doubt? Okay.
No, ma'am.
Thank you. Next class I'll okay. Next class I'll continue and take the remaining few problems, okay, related to Nernst equation. And soon I'll upload this one as well as the previous one video, okay. And I'm not send any link to your or the group. You just go through that my YouTube channel and watch that one, okay. Thank you.